How does a transformer work? To explain this, I need to recall two fundamental experiments that was previously done or explained. The first one is related to Faraday's electromagnetic induction. We said that according to this experiment, it was approved that magnetism can create electricity. Okay, and the second experiment is related to Oersted experiment, and we said as well that according to this experiment, it was approved that electricity can produce magnetism. Okay, so we can um, go from magnetism to electricity and from electricity to magnetism. And these two experiments created a new field called electromagnetism field. Okay, so a transformer uses what we call a mutual induction principle. A mutual induction principle. And what is this mutual induction principle? Actually, we talk about mutual induction principle when we have two coils. Okay, I have, for example, the second electrical circuit here, and I have the second electrical the first electrical circuit and the second electrical circuit. Okay, I have an AC voltage. They have a coil that is that is that has a current here. Okay, and there is the second coil, and I have here an induced voltage or a load. Okay, so what is this mutual induction state? It states that when two electrical coils are placed near to each other. Okay, I have two coils which are placed near to each other. AC electrical current flowing in one coil. If I have here a current that is flowing, so this will induce an AC voltage in the other coil. Okay, I have a current here that created a field. This field will induce a second field here that will create electricity. Okay, and if you focus here, we are moving from electricity to magnetism, and then from magnetism to electricity. Good. So, uh, detailed explanation. This is because current in the first coil creates a magnetic. Yeah, the first experiment, it creates a magnetic field around the first coil. The current creates here a magnetic field, which in turn induces a voltage in the second coil. Okay, so once again, we have a current that creates a magnetic field around it, and this magnetic field will induce a second magnetic field here, and this magnetic field will create electricity. Okay, so this is the mutual induction principle that is used in the transformer. Okay, here we have the components of a transformer, and how the field is being used, electrical field. The transformer uses the principle of mutual induction, as we said, and the primary coil, okay, le bobinage principal creates a magnetic field. Okay, it creates a magnetic field, as we say here, and that is concentrated. Focus on this point. That is concentrated by the core and induces a voltage. Okay, if we use if we used here an isolator, if we used here an isolator, it will not help to concentrate this magnetic field. Okay, but once we have used a ferromagnetic metal, which is the steel, it concentrated the magnetic field. Okay, and it's concentrated and preserve the magnetic field, and this will induce a voltage. Okay, and this will induce a voltage in the secondary coil. So the primary coil creates a magnetic field that is concentrated by the core and induces a voltage in the secondary coil. The voltage induced the voltage, so this voltage induced in the secondary can be used to drive a load. Okay, so how can we say that it is a step up or step down transformer? Step up means un transformateur élévateur de tension. Okay, and step down means un transformateur abaisseur de tension. Okay, so in real case, the number of turns here is essential to know, is an extremely essential point to discuss when we talk about a transformer. Okay, so the voltage at the secondary coil can be different from the voltage at the primary. Okay, and this is what is the goal of a transformer, to elevate or to reduce the voltage. So this happens when the number of turns of the coil, okay, in primary and secondary are not the same. That means if I have here 10 turns, for example, I have here 3 turns, or I have 20 turns, that will induce a different voltage from the input. Okay, and how that can be possible? I have what we call an electromotive force, okay, called here E. P refers to the primary and S refers to the secondary. I have what we call an electromotive force, okay, and this electromotive force is nothing but a voltage, a kind of voltage, theoretical voltage, okay. As they are produced by the same magnetic field, so EP, the electromotive force in the primary, is equal to the electromotive force in the secondary, because they are induced from by the same magnetic field. Okay, and this leads us to write some kind of equation that state that the voltage in the input, okay, the voltage in the input equals to what? The electromotive force, which is the voltage, multiplied by the number of turns, or the turns number. How many turns I have here? Okay, so this multiplication will induce the voltage. Okay, same thing in the secondary. The output voltage is equal to the electromotive force multiplied by the number of turns. Okay, and these equations allow us to write a new term and to define a new term, which is the turns ratio, okay, which equals to V, the voltage in the primary, to the voltage of in the secondary, equals to the number of turns in the primary to the number of turns in the secondary. It is a ratio that is defined by this equation. Okay, and this ratio is responsible to say if or to calculate if such transformer is a step down or a step up. Okay, here we have two cases. We have in the case that we have a step up transformer or a step down transformer. For example, if I have NP, the number of turns in the primary that are less than the number of turns in the secondary. Okay, so in this case, I have in the secondary, the voltage in the secondary, which is greater than the voltage in the primary. In this case, I have a step up voltage. You can take uh, numerical des chiffres numériques, and you can do the analogy. Okay. The second case, if I have NP, number of turns in the primary, which are greater than number of turns in the secondary. In this case, I have the voltage in the secondary, which is uh, smaller than the voltage in the primary, and I have a step down transformer. Okay, c'est-à-dire un transformateur abaisseur de tension. This was a theoretical part. Okay, from theory to practice, in real case, we will not find the transformer in this configuration. Okay, or placed the primary and secondary are not placed in this way. Okay, yeah. I add here the electrical representation in electrical circuits. In most cases, we have the high voltage winding, okay, is wound over the LV low voltage winding. Dans le cas général, on ne trouve pas que le primaire, l'enroulement primaire هذا, et l'enroulement secondaire يكونوا بهذه الطريقة. Ok, في le cas général, on trouve que l'enroulement de haute tension est généralement enroulé sur l'enroulement secondaire. D'accord? Donc, it is wound, il est enroulé sur. Okay, and this is the practical way to use the transformer. So here we have, I take a photo for you to see in deeper view. We have the low voltage and we have the high voltage. Okay, so in practical case, high voltage winding is wound over the LV winding. It is not in this case, but it is in this configuration. Okay. As well, we have three phases. We have one phases transformer, le transformateur à phase, à phase et le transformateur triphasé. D'accord? We have here, you can see here the secondary winding, and in green we have the primary winding. Okay? The secondary winding and the primary winding in blue. Both of the two images are for a three-phase transformer. La différence, c'est que c'est une vue de face et une vue de dessus. D'accord? Comment on voit cette transformateur? Ou bien ce transformateur. So, this was a brief explanation related to how the working principle of a transformer. Please, if you have any questions, or let them in comments, or you can send them in email. Okay, and we'll explore in the next video the types of transformer. Thank you.